Section 6 of National Geographic Magazine, Volume 1, Number 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Margaret Espaillat. The Great Storm off the Atlantic Coast of the United States, March 11th to 14th, 1888, Part 2 by Everett Hayden. The night of the 11th and 12th. Sunday afternoon at 3 o'clock, the line of the storm center, or trough, extended in a curved line, convex to the east, from Lake Ontario down through New York State and Pennsylvania, along about the middle of Chesapeake Bay to Norfolk, across North Carolina to Point Lookout, and thence down through eastern Florida to Key West. Northeasterly, easterly, and southeasterly gales were therefore felt all along the coast from the Gulf of St. Lawrence to the Florida Keys, except in the bight between Lookout and Canaveral, where the barometer had already reached and passed its lowest point, and the wind was northwest, with much cooler weather. Reference to the barometer diagram shows pretty clearly that the trough passed Norfolk a short time before it reached Hatteras, where the lowest reading was undoubtedly lower the evening of the 11th than it was at Norfolk. By 10 p.m., the line has advanced as far east as the 74th meridian. Telegraphic reports are soon all in from signal stations along the coast. The barometer is rising at Hatteras and Norfolk, and still falling at Atlantic City, New York, and Block Island, but there is little or no indication of the fury of the storm offshore along the 74th meridian, from the 30th to the 40th parallel, where the cold northwesterly gale is sweeping over the great warm ocean current, carrying air at a temperature below the freezing point over water above 75 degrees Fahrenheit, and where the barometer is falling more and more rapidly, the gale becoming a storm, and the storm a hurricane. Nor are there any indications that the area of high barometer around Newfoundland is slowing down, blocking the advance of the rapidly increasing storm, and about to hold the center of the line in check to the westward of Nantucket for days, which seem like weeks, while a terrific northwest gale plays havoc along the coast from Montauk Point to Hatteras, and until the right flank of the line has swung around to the eastward far enough to cut off the supply of warm, moist air pouring in from the southeast. Long before midnight, the welcome "Good night" message has flashed along the wires to all the signal stations from the Atlantic to the Pacific slope, whilst at sea, aboard scores of vessels, from the little fishing schooner and pilot boat to the great transatlantic liner, a life or death struggle with the elements is being waged, with heroism none the less real because it is in self-defense, and none the less admirable because it cannot always avert disaster. The accompanying track chart gives the tracks of as many vessels as can be shown without confusion, and illustrates very clearly where data for this discussion are most complete, as well as where additional information is specially needed. Thus it is here plainly evident that vessels are always most numerous to the eastward of New York, along the transatlantic route, and to the southward off the coast. To the southeastward, however, about the Bermudas, there is a large area from which comparatively few reports have been received, although additional data will doubtless be obtained from outward bound sailing vessels upon their return. Of all the days in the week, Saturday in particular is the day on which the greatest number of vessels sail from New York. The 10th of March, for instance, as many as 8 transatlantic liners got under way. Out in mid-ocean there were, plowing their way toward our coast to encounter the storm west of the 50th meridian, 1 steamship bound for Halifax, 5 for Boston, 19 for New York, 1 for Philadelphia, 1 for Baltimore, and 2 for New Orleans. Northward bound, off the coast, were 6 more, not to mention here the many sailing vessels engaged in the coasting or foreign trade, whose sails whiten the waters of our coasts. Of all the steamships that sailed from New York on the 10th, those bound south, with hardly a single exception, encountered the storm in all its fury off the coast. Eastward bound vessels escaped its greatest violence, although all met with strong headwinds and heavy seas, and, had the storm not delayed between Block Island and Nantucket on the 12th and 13th, would have been overtaken by it off the Grand Banks. Without quoting in detail the reports received, let us see what they indicate regarding the general character of the storm during the night, preparatory to our consideration of the weather chart for 7 a.m., March the 12th. To do so, be it remembered, is a very different task from that which is involved in the study and comparison of observations taken with standard instruments at fixed stations ashore. Here, our stations are constantly changing their positions. Different observers read the instruments at different hours. The instruments themselves vary greatly in quality, and while some of them have been compared with standards very recently, there are others whose errors are only approximately known. Moreover, when a vessel is pitching and rolling in a storm at sea, in imminent danger of foundering, it is of course impossible to set the vernier of the barometer scale and read off the height of the mercury with very great precision. It will thus be readily understood that the many hundreds of observations carefully taken and recorded for the hydrographic office by masters of vessels are necessarily more or less discordant, although the results obtained rest on the averages of so many reports that the probable error is always very small. An exhaustive study of reports from vessels at various positions along the coast, from the Straits of Florida to Sandy Hook, together with the records of the coast stations of the U.S. Signal Service, indicates a continuous eastward movement of the trough of low barometer during the night, accompanied by a rapid deepening of the depression. All along the coast we have the same sequence of phenomena, in greater or less intensity, according to the latitude of the vessel, as we noticed here in Washington that Sunday afternoon, when the warm southeasterly wind, with rain, died out, and after a short pause, a cold northwesterly gale swept through the city, piling up the snow in heavy drifts, with trains belated or blockaded, and telegraphic communication cut off almost entirely with the outer world. It was a wild, stormy night ashore, but it was tenfold more so off the coast, where the lights at Hatteras, Currituck, Assateague, Barnegat, and Sandy Hook mark the outline of one of the most dangerous coasts the navigator has to guard against. To bring the scene vividly before the mind would require far more time than I have at my disposal, and I can only regret that I cannot quote a few reports to give some idea of the violence of the storm. By means of a careful comparison of many reports, it is evident that although the general trough-like form of the storm remained, yet another secondary storm center, and one of very great energy, formed offshore, north of Hatteras, as soon as the line had passed the coast. It was this center, fully equal to a tropical hurricane in violence, and rendered still more dangerous by freezing weather and blinding snow, which raged with such fury off Sandy Hook and Block Island for 2 days, days likely to be long memorable along the coast. Its long continuance was probably due to the retardation of the center of the line, in its eastward motion, by the area of high barometer about Newfoundland. Thus, this storm center delayed between Block Island and Nantucket, while the northern and southern flanks of the line swung around to the eastward, the advance of the lower one gradually cutting off the supply of warm moist air rushing up from lower latitudes into contact with the cold northwesterly gale sweeping down from off the coast between Hatteras and Montauk Point. So far as the ocean is concerned, the 12th of March saw the great storm at its maximum, and its wide extent and terrific violence make it one of the most severe ever experienced off our coast. The deepening of the depression is well illustrated by the fact that the lowest reading of the barometer at 7 a.m. was 29.88 at Augusta, Georgia. At 3 p.m., 29.68 at Wilmington, North Carolina. At 11 p.m. on board the Andes, 29.35, and at 7 a.m. the following morning, it was as low as 29.20. An average rate of decrease of pressure at the center of very nearly 0.23 in 8 hours, and a maximum from reliable observations of 0.33. March 12th, 13th, and 14th. The weather chart for 7 a.m., March 12th, shows the line, or trough, with isobars closely crowded together southward of Block Island, but still of a general elliptical shape, the lower portion of the line swinging eastward toward Bermuda and carrying with it violent squalls of rain and hail far below the 35th parallel. The high land of Cuba and Santo Domingo prevented its effects from reaching the Caribbean Sea, although it was distinctly noticed by a vessel south of Cape Maysi in the Windward Channel, where there were 3 hours of very heavy rain and a shift of wind to northwest by north. The isotherm of 32 degrees Fahrenheit reaches from central Georgia to the coast below Norfolk, and thence out over the Atlantic to a point about 100 miles south of Block Island, and thence due north inshore of Cape Cod, explaining the fact that so little snow, comparatively, fell in Rhode Island and southeastern Massachusetts. From about Cape Ann it runs eastward to Cape Sable, and farther east it is carried southward again by the northeasterly winds off the Grand Banks. These northeasterly winds are part of the cyclonic system shown to the eastward of this and the preceding chart. Farther south they become northerly and northwesterly, and it will be noticed that they have now carried the isotherm of 70 degrees below the limits of the chart. Thus, this chart shows very clearly the positions of warm and cold waves relative to such cyclonic systems. First, there is this cool wave in rear of the eastern cyclonic system, then a warm wave in front of the system advancing from the coast, and finally a cold wave of marked intensity following in its train. It was probably during the night of the 12th that the lowest barometric pressure and the steepest gradients occurred. Although several vessels report lower readings, yet a careful consideration of all the data at hand indicates that about the lowest reliable readings are those taken at 10 p.m. at Woods Hall, Massachusetts, 28.92, Nantucket, 28.93, Providence, Rhode Island, 28.98, and Block Island, 29.00. The steepest barometric gradients, so far as indicated by data at hand, are also those that occurred at this time, and are as follows, taking Block Island as the initial point and distances in nautical miles. At New London, 26 miles, the barometer stood 29.11, giving a difference of pressure in 15 miles of 0.063 inch. New Haven, 62 miles, 29.36, 0.087. New York, 116 miles, 29.64, 0.083. Albany, 126 miles, 29.76, 0.090. At 7 a.m. the following day, very low readings are also reported. New Bedford, Massachusetts, 28.91, Block Island, 28.92, and Woods Hall, 28.96. The chart for 7 a.m., March 13th, shows a marked decrease in the intensity of the storm, although the area over which stormy winds are blowing is still enormous, comprising as it does almost the entire region charted. From the Great Lakes and northern Vermont to the northern coast of Cuba, the wind is blowing a gale from a direction almost invariably northwest, whilst westerly winds and low temperatures have spread over a wide tract of ocean south of the 40th parallel. North of this parallel, the prevailing winds are easterly, the isobars extending in a general easterly and westerly direction. At the storm center off Block Island, the pressure is 28.90, but the gradients are not so steep as on the preceding chart, and the severity of the storm, both ashore and at sea, has begun to diminish. About this center, too, the isobars are noticeably circular in form, showing that, although it first formed as an elliptical area, it gradually assumed the character of a true revolving storm, maintaining almost stationary between Block Island and Nantucket until it had actually blown itself out, while the great storm, of which it was a conspicuous but not essential part, was continuing its eastward progress. The enormous influx of cold air brought down by the long-continued northwesterly gale is graphically shown on this chart by the large extent and deepening intensity of the blue tint, where the temperatures are below the freezing point. From the northwestern to the southeastern portion of the chart, we find a difference in temperature of more than 80 degrees Fahrenheit, from below -10 to above 70 degrees. The steepest barometric gradient is found to the northwest of Block Island, where the pressure varies 1.80 inches in 750 miles, gradient 0.036 inch in 15 nautical miles, and 0.66 inch in 126 miles, Block Island to Albany, New York, gradient 0.079. On the chart for 7 a.m., March 14th, the depression off Block Island has almost filled up, and the stormy winds have died out and become light and variable, with occasional snow squalls. The other storm center has now regained its ascendancy and is situated about 200 miles southeast from Sable Island, with a pressure about 29.3. The great wave of low barometer has overspread the entire western portion of the North Atlantic, with unsettled, squally weather from Labrador to the Windward Islands. The area of high pressure in advance has moved eastward, to be felt over the British Isles from the 17th to the 21st of the month, followed by a rapid fall of the barometer as this great atmospheric disturbance moves along its circuit round the northern hemisphere. The isotherm of 32 degrees is still south of Hatteras, reaching well out offshore, and thence northward, tangent to Cape Cod, as far as central Maine, and thence eastward to St. John's, Newfoundland. Great contrasts of temperature and pressure are still indicated, but considerably less marked than on the preceding chart, and the normal conditions are being gradually restored. Conclusion. The great storm that has thus been briefly described, as well as can be done from the data now at hand and in the limited time at our disposal, has furnished a most striking and instructive example of a somewhat unusual class of storms, and this on such a grand scale, and in a part of the world where the data for its study are so complete that it must long remain a memorable instance. Instead of a more or less circular area of low barometer at the storm center, there is here a great trough of low between two ridges of high, the whole system moving rapidly eastward and including, within the arc of its majestic sweep, almost the entire width of the temperate zone. The trough phenomena, as an eminent meteorologist has called the violent squalls, with shifts of wind and change of conditions at about the time of lowest barometer, are here illustrated most impressively. Such changes are, of course, to be expected and guarded against in every storm, and sailors have long ago summed them up to store away in memory for practical use when occasion demands, in the well-known lines, "First rise after low indicates a stronger blow." One thing to which attention is particularly called is the fact that storms of only ordinary severity are likely, upon reaching the coast, to develop greatly increased energy. As has been already pointed out, there can be no doubt but this is especially so in a storm of this kind, where the isobars are elongated in a north and south direction. The accompanying barometer diagram, if studied in connection with the track chart and the weather chart for March 11th, illustrates very clearly this deepening of the depression at the storm center. The formation and persistency off Block Island of a secondary storm center of such energy as was developed in this case, however, it would seem wholly impossible to have foretold, and a prediction to that effect made under similar circumstances would probably prove wrong in at least 9 cases out of 10. But it may be safely said that the establishment of telegraphic signal stations at outlying points off the coast is a matter of great importance, not only to our extensive shipping interests, but to the people of all our great seaboard cities as well. To the northward, telegraphic reports from such stations would furnish data by which to watch the movement of areas of high barometer, upon which that of the succeeding low so largely depends, and to the southward, to give warning of the approach and progress of the terrific hurricanes which, summer after summer, bring devastation and destruction along our Gulf and Atlantic coasts, and of which this great storm is an approximate example and a timely reminder. In this connection also, there is another important result to be gained. Scientific research and practical inventive genius, advancing hand in hand for the benefit of mankind, have discovered not only the laws governing the formation of the dense banks of fog that have made the Grand Banks dreaded by navigators, but also the means by which certain facts may be observed, telegraphed, charted, and studied 1,000 miles away, and the occurrence of fog predicted with almost unfailing accuracy, even whilst the very elements themselves are only preparing for its formation. By means of such predictions, the safety of navigation along the greatest highway of ocean traffic in the world would be vastly increased. Routes traversed yearly at almost railway speed by vessels entrusted with more than 1 million human lives and property of an aggregate value of fully $1 billion. What is everybody's business is too often nobody's business, and if no single nation is going to undertake this work, an international Congress should be formed to do so, with full authority to act and power to enforce its decisions. Probably nothing will more forcibly attract the attention of the practical navigator than the new and striking illustrations which have been furnished by reports from various masters of vessels caught in the terrific winds and violent cross seas of this great storm, relative to the use of oil to prevent heavy broken seas from coming on board. Although this property of oil has been known from time immemorial, it has only recently come into general use, and it is good cause for congratulation, considering the great benefits to be so easily and so cheaply gained, that the U.S. Hydrographic Office is acknowledged to have taken the lead in the revival of knowledge regarding it, and in its practical use at sea. It is difficult to select one from among the many reports at hand, but the following brief extract from the report made by Boat Keeper Robinson in behalf of the pilots of New York Pilot Boat No. 3, the Charles H. Marshall, cannot fail to be read with interest. The gallant and successful struggle made by the crew of this little vessel for 2 long days and nights against such terrific odds is one of the most thrilling incidents of the storm, and well illustrates the dangers to which these hardy men are constantly exposed. The Charles H. Marshall was off Barnegat the forenoon of the 11th, and as the weather looked threatening, 2 more reefs were put in the sails, and she was headed to the northward, intending to run into port for shelter. During the afternoon the breeze increased to a strong gale, and sail was reduced still further. When about 18 miles southeast from the lightship, a dense fog shut in, and it was decided to remain outside and ride out the storm. The wind hauled to the eastward toward midnight, and at 3 a.m. it looked so threatening in the northwest that a fourth reef was taken in the mainsail, and the foresail was treble reefed. In half an hour the wind died out completely, and the vessel lay in the trough of a heavy southeast sea that was threatening every moment to engulf her. She was then about 12 miles east-southeast from Sandy Hook Lightship, and in 20 minutes the gale struck her with such force from the northwest that she was thrown on her beam ends. She instantly righted again, however, but in 2 hours was so covered with ice that she looked like a small iceberg. By 8 a.m. the wind had increased to a hurricane, the little vessel pitching and tossing in a terrific cross sea, and only by the united efforts of the entire crew was it possible to partially lower and lash down the foresail and the forestaysail. No one but those on board can realize the danger she was in from the huge breaking seas that rolled down upon her. The snow and rain came with such force that it was impossible to look to windward, and the vessel was lying broadside to wind and sea. A drag was rigged with a heavy log, anchor, and hawser to keep her head to sea and break the force of the waves, but it had little effect, and it was evident that something must be done to save the vessel. 3 oil bags were made of duck, half filled with oakum saturated with oil, and hung over the side forward, amidships, and on the weather quarter. It is admitted that this is all that saved the boat and the lives of all on board, for the oil prevented the seas from breaking, and they swept past as heavy rolling swells. Another drag was rigged and launched, although not without great exertion and danger, and this helped a little. Heavy iron bolts had to be put in the oil bags to keep them in the water, and there the little vessel lay, fighting for life against the storm, refilling the oil bags every half hour, and fearing every instant that some passing vessel would run her down, as it was impossible to see 100 feet in any direction. The boat looked like a wreck. She was covered with ice, and it seemed impossible for her to remain afloat until daylight. The oil bags were replenished every half hour during the night, all hands taking turn about to go on deck and fill them, crawling along the deck on hands and knees and secured with a rope in case of being washed overboard. Just before midnight, a heavy sea struck the boat and sent her over on her side. Everything movable was thrown to leeward, and the water rushed down the forward hatch. But again she righted, and the fight went on. The morning of the 13th it was still blowing with hurricane force, the wind shrieking past in terrific squalls. It cleared up a little towards evening, and she wore around to head to the northward and eastward, but not without having her deck swept by a heavy sea. It moderated and cleared up the next day, and after 5 hours of hard work, the vessel was cleared of ice and set sail for home. She had been driven 100 miles before the storm, fighting every inch of the way, her crew without a chance to sleep, frostbitten, clothes drenched and no dry ones to put on, food and fuel giving out, but they brought her into port without the loss of a spar or a sail, and she took her station on the bar as usual. Do the pages of history contain the record of a more gallant fight? Nothing could show more graphically than this brief report the violence and long duration of the storm. No wonder that this terrific northwest gale drove the ocean itself before it, so that the very tides did not resume their normal heights for nearly a week at certain ports along the coast, and the Gulf Stream itself was far south of its usual limits. The damage and destruction wrought ashore are too fresh in mind to be referred to here, and losses along the coast can only be mentioned briefly. Below Hatteras there was little damage done to shipping. In Chesapeake Bay, 2 barks, 77 schooners, and 17 sloops were blown ashore, sunk, or damaged. In Delaware Bay, 37 vessels. Along the New Jersey coast and in the Horseshoe at Sandy Hook, 13. In New York Harbor and along the Long Island coast, 20, and along the New England coast, 9. The names of 6 vessels that were abandoned at sea have been reported, and there are at least 9 others missing, among them the lamented New York pilot boats Phantom and Enchantress, and the yacht Cythera. Several of these abandoned vessels have taken their places amongst the derelicts, whose positions and erratic tracks are plotted each month on the pilot chart, that other vessels may be warned of the danger of collision. The schooner W.L. White, for instance, started off to the eastward in the Gulf Stream, and will soon become a source of anxiety to the captains of steamships along the transatlantic route, and furnish a brief sensation to the passengers when she is sighted. There is thus an intensely human side to the history of a great ocean storm, and to one who reads these brief records of facts and at the same time gives some little play to his imagination, there is a very pathetic side to the picture. In the words of Longfellow, "I see the patient mother read, with aching heart, of wrecks that float, disabled on those seas remote, or of some great heroic deed on battlefields where thousands bleed, to lift one hero into fame. Anxious she bends her graceful head above these chronicles of pain, and trembles with a secret dread, lest there among the drowned or slain she find the one beloved name." End of section 6.